Today we're going to start working on lesson 2.6, which is solving proportions. So we're going to solve proportions using cross products. We'll use some distributive property here as well, and then we'll look at some applications of how proportions can be used in the real world. First of all, some key terms and concepts. Obviously, the word proportion is new to us, and basically what it's saying is that two ratios are equivalent. All right, now ratios are a comparison of two numbers, and typically we write that comparison as fractions. All right. And what we know about this is that if we truly have a proportion, then the cross products have to be equal. If two ratios are truly equal to one another, then the cross products are going to be equal. So what we're saying is if the ratio of A to B is equal to the ratio of C to D, if this is true, then A times D has got to be equal to C times B. And this is where we get our equations from in work today. Okay. So an example, we know 1/2 is the same as 5 out of 10, right? We know 1/2 equals 5 to 10. So if you do cross products, 1 times 10 is 10, 2 times 5 is 10, that confirms it. All right. So if cross products are equal, then these two ratios are the same, they're equivalent. Okay. So some of the questions we're going to have tonight, at least starting out wise, is going to be real simple. It's going to be this, like the ratio of 3 to 7 is equal to the ratio of x to 6. What does x have to be to make this true? Well, we know 3 out of 7 and x over 6 are our given problem, so we do cross products. 7 times x is equal to 3 times 6. And as far as cross products go, it doesn't matter which one you want to put on the left side or the right side of the equal sign. I usually do the cross product that involves the x and put that on the left and then put the other one on the right. Okay, so we got 7x is going to equal 18. We're trying to solve for x as being multiplied by 7, so we're going to divide each side by 7, and we're going to get x is about 2.6. It said round to the nearest tenth if necessary. Okay, so since it gave us that opportunity, we did it. If not, we would have left it as the fraction 18/7. Pretty straightforward. I'm sure you've done it before. Another one, x over 45 equals 15 over 25. So the ratio of x to 45, we want that to be the same as the ratio of 15 to 25. Okay, so it doesn't matter where the x is. As long as I got 3 of these and 1 missing, I can find the missing. So again, if these two are going to be equal, then their cross products have to be equal. So x times 25 has got to equal 45 times 15. 25x equals 675. Divide each side by 25, and we get x is 27. So the ratio of 27 to 45 is equal to 15 out of 25. Okay, those two are the same. Now, this one's a little bit more complex because they give us an expression up here rather than just a variable by itself. So this is saying they want the ratio of n minus 4 to 8 to be the same as the ratio of 3 to 2. So I want this expression, the ratio of this expression to 8 to be the same as the ratio of 3 to 2. Well, we do it the same way, cross products. Now, the thing about our cross products are it's 2 times this expression. So I got to put that in parentheses, and then 3 times 8 on the other side. So when I have the quantity of n minus 4 times 2, I got to distribute. So we're going to get 2n minus 8 equals 24. Now we got a little two-step equation, so we'll add 8 to each side to make this become a 0 right here, right? Negative 8 plus positive 8, 0. So we get 2n equals 32. We'll divide each side by 2 and get it should say n equals 16. Okay, so for this to be true, our n's got to be 16. So when you put 16 in here, 16 minus 4 is 12. So the ratio of 12 to 8 is the same as 3 to 2. Now think about that. 2 times 12 is 24. 3 times 8 is 24. So n's got to be 16 for this to work. Okay. Another example. I got another expression up here, not just a variable by itself, but an expression. Okay. Now I also have a variable on this side. Okay. But we just do what we talked about, cross products, right? So the ratio of x to 9, we want to be the same as the ratio of 2x minus 3 to 24. Okay, so cross products. 24 times x has got to equal 9 times 2x minus 3. Again, it's 9 times a quantity. This is grouped. If it's in the top of a fraction, it's grouped. Okay, so 24 times x is 24x. Distribute our 9, we get 18x minus 27. Okay, now we got an equation with variables on each side. Okay, I don't want variables on both sides, so I got to make one of them a 0. It makes sense to make the 18x a 0 because then I'll have the variable on the left and the number on the right remaining. So we're going to subtract 18x from both sides. So our original 18x minus 18x, that's 0. 24x minus 18x, that's 6x. So 6x equals negative 27. Okay, now I want to get the coefficient on my x here to be a 1 rather than a 6. So divide each side by 6, and we get x is about negative 4.5. Okay, so about negative 4.5 is what we're going to get here for x. Okay, and if we put that ratio in, it'll be true. Okay, or put the value in for x here. To both of those, it will be true. Okay, another example of this. So Amanda runs 3 miles in 28 minutes. At that same rate, how many miles could she run in 42 minutes? Be sure to include units in your answer. So what we're looking at when we set up these ratios is we're looking for a ratio of miles to minutes. How many miles does she run and how many minutes? And then our second ratio, because we want to write a proportion, so we want to write two ratios equal to each other. Also has to be miles to minute. So we know she can run 3 miles in 28 minutes. So the question is, how many miles, x, can she run in 42 minutes? So miles to minutes, miles to minutes. My unknown is this x. I'm trying to find the value of x that makes the ratio of this number to 42 the same as 3 to 28. Okay, cross products. 28x equals 3 times 42. 28x equals 126. Divide each side by 28, and we get x is 4.5. So if she can run 3 miles in 28 minutes, she's going to be able to run 4.5 miles in 42 minutes. Okay, so we express our answer here in a statement and we include units. All right, that's an example of using a proportion. Okay, got another example here. So the ratio of men to women working for a company is 2 to 3. If there's 57 women working for the company, what's the total number of employees? Be sure to include units in your answer. Okay, now let's talk about this a little bit here. So the ratio of men to women working is 2 to 3. So I know men to women is 2 to 3. But we also have more information with this. Okay, because if you look, they're asking us what is the ratio of the women to total employees. So what's the ratio of men to total employees? Well, the men, if men to women is 2 to 3, and then men to total employees would be 2 to 5. There's two men to every 3 women, so there's a total of 5 people, and out of those 5, 2 are men. Okay, what's the ratio of women to total employees? Well, 3 out of every 5 are women, so the ratio of women to total employees would be 3 to 5. So when they give us the ratio of men to women, we can convert it to men to total employees or women to total employees. Okay, so that's kind of a key catch there. So if you look at what they're asking, they're saying, okay, if there's 57 women working for the company, what's the total number of employees? So which one of these do we want to use here? Well, we want to use the one that has women compared to total employees. Okay, so we're going to go women to employees, and my second ratio is going to be women to employees. So I know the ratio of women to employees is 3 to 5. I want to know how many employees, X, when 57 of these employees are women. So 3 out of every 5, 57 out of how many would be the same ratio? Okay, cross products. 3x equals 5 times 57. 3x equals 285. Divide each side by 3. X is 95. So there's 90. If 57 employees work for the company, if 57 women work for the company, and the ratio is 3 to 5, then 95 in total employees are at this company. Okay, 57 out of 95 is the same as 3 out of 5. Okay, so there's a little application. You got to read into that question a little bit. You just can't use these two numbers as is. You got to look at what they represent and how else could we see it. That's what these other two were. Okay, all right. So if you go to your online text, there's more examples of this. Okay. This says complete the online assessment. So what you're going to do, guys, is you're going to go to Alex and do your homework as you always do. All right, so it's a pretty straightforward lesson. Write out the work, keep it on a separate sheet of paper, be ready to turn that in. Okay, all right, I'll let you get at it.